Hello students, and in this class we will discuss the second part of integration miscellaneous exercise. In the last session we discussed until question number 6 of the integral calculus. So let us start our session with the question number 7 of miscellaneous exercise of integral calculus. Question number 7, integral of seventh question, integral of sin x by the denominator and sin of x minus a, sin of x minus a dx. So we can integrate this particular question using either substitution method or adjustment method, but both are the same kind. What to do? The first angle should be written in terms of the second angle. Theta 1 first angle, numerator angle should be written as a function of the denominator angle theta 2. This is the concept. So theta 1 is x and theta 2 x minus a. How to write theta 1? X, it should be written x minus a and plus a. X is theta 1, x minus a theta 2. Now we have written x in term of theta 2, that is theta 1 in term of theta 2. Now we can start. The numerator angle x can be taken x minus a and plus a. So we have converted basic angle into compound angle. A denominator angle, there should not be any change. Whatever adjustment you require, do only in the numerator angle in terms of a denominator angle. This is basic concept. Dear student, the sin of x minus a plus a, this is like a sin of a plus b. We can expand using compound angle formula. Sin of a plus b, sin a cos b plus cos a sin b, sin a x minus a and cos b is cos a, and plus cos a is x minus a, and sin of the second angle a, the denominator sin of x minus a. There is no change in the denominator. On simplification, the first term sin of x minus a divided by sin of x minus a becomes unit factor. Then cos a alone left. The first integral. The second one, sin a is taken as coefficient. Yes, real number. Integral of cos of x minus a by sin of x minus a, cot of x minus a. So now both the terms integrable. So we can write here final answer. Cos a is constant. So cos a in the integral of dx. What is integral of dx? X. So the integral of the first term x into cos a, and sin a coefficient, integral of cot log mod of and sin of x minus a with integral constants. Dear student, this is the final answer of the question integral of sin x by sin of x minus a. Remember student, what is the point to be noted? You can apply the same procedure for and cos theta 1 by and cos theta 2 or sin theta 1 by and cos theta 2 or cos theta 1 by sin theta 2. different combination, different angle. So we have to write the first angle in term of the second angle. You can apply the same method to get the answer. Okay, and copy it. We'll go to next question. Next question, and question number 8 from the miscellaneous exercise. Integral of and e power 5 log x minus e power 4 log x, the denominator e power 3 log x and minus e power 2 log x. And point to be noted for this type of question is a general case. A power n log x to the base a. The logarithmic base a and the exponential term same base a. Both are equal. A power n log of x to the base a is nothing but x power n. Is nothing but x power n. Okay, why? And a power x and log x to the base a are inverse to each other. Similarly, and e power n log x to the base c, the two terms should be same, then this is nothing but same x power n. This is general result. A power n log x to the base a equal to x power n. Here e power n log x to the base e equal to x power n. Applying this conversion rule, we can have simplified form of the question. I e power 5 log x x power 5, e power 4 log x x power 4, e power 3 log x x cube, e power 2 log x x square. And further simplification, we can take x square common factor from the denominator, then x square cancel mean x cube minus x square, the denominator x minus 1, the denominator x minus 1. Okay, this is a kind of improper integral. Why? The exponent of numerator 3, the exponent of denominator 1. So this is an improper integral. We should go by long division method to write quotient plus remainder by divisor. Or the numerator is factorizable further, x square into x minus 1, correct, by x minus 1. X square and x minus 1, x cube minus x square is written, x square and x minus 1 and dx. Now we can write its lowest term after cancelling common factor between numerator and the denominator. Now what is the factor left? Only x square factor is left, x square dx. So we can have our final answer x cube over 3 with an arbitrary constant known as integral constant. So this is the final answer and copy it. Okay, then we'll move to the next question, question number 9. Integral of and cos x the denominator root of 4 minus sine square x. Very normal question. If we look for the connectivity within the integrand, we have cos x factor and sin x is one of the term from the denominator. What is the connectivity? We can write cos x as a derivative of minus sin x. So derivative of sin x cos x, not minus sin x. Directly we can have derivative of sin x. Then what is the integration? Yes, we have to take sin x as a t, so that we can write cos x dx dt. So we should go by substitution method. Solution: let t can be taken as sin x, so that the differential of t will be equal to cos x and dx. Cos x and dx. Differential of and sin x is cos x and dx. Now we can convert the given integral in terms of the newly introduced and variable t. Then cos x dx is replaced by dt, and root of 4 minus t square. This is familiar formula. Integral of dx by a root of a square minus x square is sine inverse of t by a. A is 4 is nothing but 2 square, a equal to 2. My dear student, and we are going to present final answer in term of the given variable t. What is t? Sin x. So sine inverse of sin x by 2. Dear student, leave with this is the final answer. Don't simplify sine inverse of sin x by 2 as x by 2. Don't cancel between sine inverse and sine. If you do not have the 2 factor, sine inverse of sin x straight away can be written as x. The sine inverse of an alpha into sin x, or cos inverse of some scalar into cos x, and should be left as it is, and don't and simplify further. It cannot be simplified, then your answer will be incorrect. Make note of it. Okay, this is question number 9. We'll go to the next question. Question number 10. Integral of and sine power 8x minus cos power 8x the denominator 1 minus 2 sine square x into cos square x and dx. So we can use identity. What's the identity? A power 8 minus b power 8, a minus b into a plus b. This is a square minus into a square plus b square, a square minus a power 4 minus b power 4 into a power 4 plus b power 4. Correct? So a minus b into a plus b, a square minus b square, a square minus b square into a square plus b square, a power 4 minus b power 4 into a power 4 plus b power 4, a power 8 minus b power 8. Okay? So remember the identity. Remember the identity. And if we take, and a is instead of sin x, sin square x, and b is and cos square x, and The fourth factor is not required. So sine square x minus cos square x, sine square x plus cos square x, sine power 4 x plus cos power 4x. So this is a way solution. Then how to write numerator? First term sine square x minus cos square x. Another factor sine square x plus cos square x. Another factor sine power 4x plus and cos power 4x. Okay. At present, not to disturb the denominator. At present, not to disturb the denominator. So we can have the same denominator. And 1 minus 2 sine square x into cos square x. Clear? If we continue the simplification process, and sine square minus cos square x minus cos 2x. Correct? Yes, cos square x minus sine square x is cos 2x. Here the terms of interchange, sine square x minus cos square x will be equal to minus cos 2x. And the next factor is 1, identity. The third factor can be written and sine square plus cos square whole square minus and 2ab, that is 1 minus 2 sine square x and cos square x. This, remember sine power 4x plus cos power 4x is nothing but 1 minus 2 sine square x cos square x. Okay. Then a denominator is retained without any change. 1 minus 2 sine square x and cos square x. And to go to a lowest form of the present one, the common factor can be and cancelled between numerator and the denominator. Then minus integral of only cos 2x is left for integration. Only cos 2x is left for integration. This implies I will be equal to what is integral of and cos ax. Integral of cos ax sin ax by a. So final answer minus sin 2x over 2 with the integral constant. So this is the final answer of the question, sin power 8x minus cos power 8x. So divided by 1 minus 2 sin square x into cos square x. Copy it. Okay. And we'll go to next question. 11th question. Let's copy it first. And question number 11. Integral of dx over cos of x plus a. Cos of x plus a. One more factor and cos of x plus b. Okay, how to deal this kind of question? In the denominator and cos a cos b or cos theta 1 cos theta 2. So cos theta 1 into cos and theta 2, it can be and part of and cos of theta minus 1 is a part of cos of theta minus 1 of the term of is one of the terms of cos of theta 1 minus theta 2. Am I correct? Why not cos theta 1, cos theta 2 is one of the terms of cos of theta 1 plus theta 2. Correct, absolutely correct. But for adjustment, we need constant term. Theta 1 plus theta 2 won't be constant. 2x plus a plus b. But theta 1 minus theta 2 is constant. So theta 1 x plus a, theta 2 x plus b. What is theta 1 minus theta 2? A minus b. We need constant. The compound angle should be constant. The compound angle constant means theta 1 minus theta 2. The denominator is one of the term of and cos of theta 1 minus theta 2 means we need adjustment, multiply and divide the given integrand by the same compound angle but different ratio. That is, 4 ratio should be taken, multiply and divide by sine of theta 1 minus theta 2. This is the concept, most important concept, the most important concept. Clear all of you? Okay. Then sine of theta 1 minus theta 2, x plus a minus of x plus b. Then sine of x minus a minus of x minus b, sine of a minus b. In order to retain the equality, the outside we have to divide the same quantity. Then a minus b, sine of a minus b. There should not be any change in the denominator. Whatever adjustment you need, or you look for any kind of adjustment in integral, do only in the numerator without affecting denominator. Then cos of x plus a into cos of x plus b dx. So let us expand the numerator. This is I 1 over sine of a minus b integral of expanding numerator sine of a minus b, sine a cos b minus cos a sine b, sine of first angle and cos of second angle, x plus a, x plus b, and minus cos of first angle x plus a and sine of the second angle x plus b. This expansion of the numerator using compound angle formula. Denominator should be retained without any change. Cos of x plus a, one more factor, cos of x plus b, then dx. Now we can split up 1 by sine of a minus b integral of, and cos of x plus b, cos of x plus b cancel in first term, sine by cos tan of x plus a minus, and cos x plus a, cos x plus a cancel second term, and tan of x plus b. So we can integrate using regular formula 1 by sine of a minus b. Dear student, what is integral of tan? Log mod of secant of the angle x plus c and minus log mod of secant of x plus b with integral constant. So dear student, so let us wind up on today's session with the question number 11. Now this is second part of the miscellaneous exercise of the chapter integral calculus. In the third session, we can continue with the question number 12 of miscellaneous exercise of the same chapter, integral and calculus. And thank you students, and go through it. We'll meet in the next class.